Welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 1. So question number 1 is the angular frequency of oscillation of a quantum harmonic oscillator in 2 dimension is omega. If it is in contact with an external heat bath at temperature T, its partition function is, that's what we need to find out. 4 options are given and we need to find out the correct option. So let's start. So here the question comes from the section of Statistical Mechanics, and the concept involved here is the partition function. So in order to answer this question, you should have a thorough understanding about the partition function. So what is partition function? Now consider a system of a very large number of particles at or near thermal equilibrium. Now let us suppose the total energy of the system is E and the total number of particles is N. Now this total energy E has to be distributed among the available energy of the system. Basically what is happening here is the total energy E is shared among all the particles, and depending on the energy, the particles are distributed over available energy level. Or in other words, particles are partitioned among different energy levels. That is why the name partition function. And this process is done by using the Boltzmann distribution. So mathematically the partition function is represented by the symbol Z, and the formula is Z is equal to summation over Gi e to the power minus beta Ei. So here Ei is your energy of the ith state of the system. Gi is the degeneracy of the ith state, and this beta is equal to 1 by kBt, where kB is your Boltzmann constant and T is the absolute temperature. So now let's start solving this problem. Now here the system is the 2-dimension harmonic oscillator. So here I will explain the solution in 2 ways. One will be in a detailed manner and another will be a shortcut way. So first do it in a detailed manner. Now as already mentioned, the mathematical expression of the partition function is Z is equal to summation over Gi e to the power minus beta Ei. Now for 2-dimension harmonic oscillator, this energy is equal to E is equal to n plus 1 h cross omega. Now as it is a 2-dimension harmonic oscillator, so it is represented by 2 different quantum numbers nx and ny. So this we can write as nx plus ny plus 1 h cross omega. So here E we will represent as E nx ny, and here n is equal to nx plus ny, as I already said. So now we have to calculate the energy of the different states along with the corresponding degeneracy. That is, for each of different states we have to calculate Ei and the corresponding Gi. And let's start with the ground state. So for ground state, this n, quantum number n is equal to 0. Now this n equal to 0 means nx is equal to 0 and ny is equal to 0. So the energy here will be E00 equal to h cross omega. Now since this is a non-degenerate state, so the degeneracy G1 is equal to 1. Now let's talk about the first excited state energy. So here n will be equal to 1. So for n to be equal to 1, there will be two possibilities for nx and ny. So either nx is equal to 1 or ny equal to 0, or nx equal to 0, ny equal to 1. In both the cases, n will be equal to 1. So in that scenario, the energy will be E10 is equal to E01 is equal to 2h cross omega. Now in this scenario, this energy 2h cross omega is achieved with two possibilities of the quantum state. That is, two combinations are there for nx and ny to get the same energy value. So we can say that it is a twofold degenerate. So the degeneracy G2 is equal to 2. Now let's talk about the second excited state. Now for second excited state, n is equal to 2. Again, this n is equal to 2 means nx and ny will have different combinations. So the combinations will be nx equal to 1 and ny equal to 1, or nx equal to 2 and ny equal to 0, or nx equal to 0 and ny equal to 2. Now here the energy will be E11 equal to E20 equal to E02 is equal to 3h cross omega. So again here this energy is achieved by three possible combinations of the quantum states. So this is a threefold degenerate. That means the degeneracy G3 will be equal to 3. Now let us calculate the partition function. So this expression z is equal to summation over gi e to the power minus beta ei. Now let's put the value of gi and the corresponding ei values here. So first this will be gy equal to 1, so 1 into e to the power minus beta h cross omega plus 2 into e to the power minus beta 2h cross omega plus 3 into e to the power minus beta 3h cross omega. So here we have put the value of G1, E1, G2, E2 and G3, E3 in the corresponding expression, and this is the expression we have got. So now here if we take common e to the power minus beta h cross omega from all these terms, so what we will get is equal to e to the power minus beta h cross omega within bracket 1 plus 2 e to the power minus beta h cross omega plus 3 e to the power minus beta 2h cross omega and so on. So now this expression can be solved, this bracketed expression can be solved by using a series expansion formula. So the formula is 1 minus x to the power minus 2 is equal to 1 plus 2x plus 3x square and so on. So here if we choose x is equal to e to the power minus beta h cross omega, then this expression is same as this. So here we can use this expansion instead of this expansion we have to use in this form, in this expression. So instead of this long expression we can substitute it with a shorter version of expression like this. So instead of x we have to use e to the power minus beta h cross omega here and put it in this expression. So by using this formula, expression of z will be equal to e to the power minus beta h cross omega 1 minus e to the power minus beta h cross omega whole to the power minus 2, which will be equal to e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega whole square. So this is the partition function for the two-dimension harmonic oscillator. Now as I told you that I will explain it in a shortcut way. So let's do that. So for shortcut way, what you need is, you need to remember the partition function for the one-dimension harmonic oscillator. And from that expression, we can directly derive the partition function for the two-dimension harmonic oscillator. So partition function for one-dimension harmonic oscillator is Z is equal to e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. So in order to calculate the partition function for the two-dimension harmonic oscillator, here what we have to do is, the partition function Z will be equal to the square of this term. Okay, so the partition function for two-dimension harmonic oscillator will be square of this expression. So that means we can write this as e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega into e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. So this is equal to e to the power minus beta h cross omega divided by 1 minus e to the power beta h cross omega whole square. Now what we can do here is, in the denominator, here we will take common e to the power minus beta h cross omega. So this expression will be e to the power minus beta h cross omega divided by, in the denominator after taking common, it will be the bracket start e to the power minus beta h cross omega into e to the power beta h cross omega minus 1 whole square. So now after taking out this term out of the square, out of the bracket, this will be equal to e to the power minus beta h cross omega divided by e to the power minus 2 beta h cross omega into e to the power beta h cross omega minus 1 whole square. So here this term, when go towards the numerator, it will ultimately give e to the power beta h cross omega in the numerator. So the final expression will be e to the power beta h cross omega divided by e to the power beta h cross omega minus 1 whole square. So as you can see, this is the same expression which we have got in the earlier method also. So this is the partition function for the two-dimension harmonic oscillator. Now let's look at the options. Now if you look at the options, you can see that option B is matching with our result. So the correct answer for this question is option B.